Hurricanes, colossal swirling engines of wind and rain, are among nature's most powerful forces. Born over warm tropical oceans, they move heat from the equator toward the poles, balancing our planet's climate. Known as hurricanes, typhoons, or cyclones depending on location, their story is always one of immense power. From space, they appear as spirals of white clouds with a calm eye at the center, surrounded by the violent eye wall. These storms require specific conditions: warm ocean water, moisture, and the Earth's spin. When these elements align, a gentle disturbance can transform into a raging tempest. Hurricanes have shaped coastlines and ecosystems for millions of years, impacting both wildlife and human communities. By understanding how they form, we can better prepare for their arrival and respect the raw power of our planet. Let's explore the journey from a quiet ocean to a mighty hurricane. Every hurricane begins over warm tropical waters where the sun heats the ocean's surface to at least 26.5 degrees Celsius. This warmth fuels the storm, causing water to evaporate and rise as moist air. As the air ascends, it cools and condenses into towering thunderclouds, releasing latent heat. This heat makes the air rise even faster, lowering surface pressure and drawing in more warm, moist air. The process becomes a self-sustaining loop, with new air rising, cooling and releasing more energy. This cycle organizes scattered thunderstorms into a growing system. The low-pressure center acts like a vacuum, pulling in air from all directions. With each cycle, the storm intensifies, feeding on the endless supply of ocean heat. Soon, a cluster of storms begins to organize, setting the stage for hurricane formation. The engine is running, powered by the ocean below. As air rushes toward the low-pressure center, Earth's rotation introduces the Coriolis effect. This force deflects winds, right in the northern hemisphere, left in the southern, giving hurricanes their signature spin. Instead of moving straight in, winds spiral around the center, forming a rotating vortex. This organized spin shapes the storm's spiral rain bands and is crucial for its development. The conservation of angular momentum causes winds to accelerate as they spiral inward, much like a figure skater pulling in their arms. At the center, a calm eye forms, surrounded by the eye wall, the most intense part of the storm. The eye signals a mature, powerful hurricane with strong, efficient circulation. Without the Coriolis effect, the storm's energy would dissipate, but with it, the hurricane grows stronger and more structured. The result, a perfectly balanced engine of wind and rain, ready to travel across the ocean. The hurricane's journey continues, driven by rotation and energy. A mature hurricane is a complete weather system, fueled by extreme pressure differences and ocean heat. Its winds can exceed 150 miles per hour, but rain and storm surge are equally destructive. Torrential rainfall can cause catastrophic flooding and landslides, even far inland. The storm surge, a dome of water pushed ashore by hurricane winds, can inundate entire coastal towns in hours. This surge, often combined with high tides, is the deadliest aspect of hurricanes. By studying these storms, we improve our ability to predict, prepare, and protect our communities. Hurricanes remind us of the immense energy that shapes our world. Stay curious, stay prepared, and respect the power of nature.